electric potential difference right now, and we're really just going to talk about generally sort of what it is, and in the next video we will talk about, I'll give you an exact form for the electric potential, but let's talk about what the electric potential difference is. I may drop and say just electric potential. I always mean the electric potential difference, but I'll try to keep on top of that. So let's just make a list and let's talk about what is delta V. So first of all, it's a thing that exists in space. Just like the electric field, it exists everywhere in space. The electric potential difference can also exist everywhere in space. It tells a charged object the change in potential energy between 2 points. So remember that our electric potential energy that you just saw previously is equal to Q test times this electric potential difference. So our electric potential difference is telling our Q test about the change in that potential energy between 2 different points. What this also means is that we can set a reference point, and we usually set a reference point for something to be infinitely far away, the potential to be 0 there. But that also means that we could define 0 to be anywhere in our system. Very similar to how we treat gravitational potential energy, where we can treat maybe the ground as 0 gravitational potential energy, and you gain gravitational potential energy as you increase in height. So it's a similar sort of way we can set our zero point for our electric potential difference to be anywhere that we want. So this will come up a little bit later too. This we talked about in the previous video. Our electric potential difference has units of joules per coulomb, and we have a shortcut unit for joules per coulomb, which is a volts, given by the V symbol, units of volts. It's a scalar, so notice I don't have a vector on this. It's different from the E field in that way. The electric field has a direction, the electric potential difference does not. It's just a scalar. And this is kind of combined with this last point here, right? It's a field. It can be different at every point in space, but it does not have a direction. A similar thing that is that we can sort of treat in a similar way is like temperature. Temperature is a scalar field, right? I'm standing over here, it might be one temperature, and if I stand over here, it could be a different temperature. And it's a similar sort of way with the electric potential difference field. Okay, so I think that's all that I wanted to say about generally what is the electric potential difference, and we'll look at an exact form for the electric potential difference in the next video.